Welcome. In this video we'll learn about generating audio signal. Let's see how we can generate one such signal. We can use NumPy package to generate various audio signal. Since audio signals are mixtures of sinusoids, we can use this to generate an audio signal with some predefined parameters. Let's open my directory which contain my file. I have already written a script, that is audiogenerator.py. Now let's move to the output now. Let's open the terminal. Run the command as python space audiogenerator.py. You can see that it generated one audio signal for time dimensions and amplitude. Another thing it has generated is one audio which we can play, and it contains noise. So let's play it and listen. The sound is generated. Now let's see the coding part of it. The first one is import NumPy as np, which you all know for what purpose we use it. Next, import matplotlib.pyplot as plt. This also I have discussed in the previous video. And next, from sciencespy.io.wave file import write. This scipy, that is sciencespy, is an open source Python library used for scientific computing and technical computing. The output file where the audio file will be saved, that is output file equals to generated audio.wave. Now specify the audio parameter such as duration, that is 4 seconds, sampling frequency, that is 44100 in Hertz, tone frequency 784, minimum value, maximum value. That's it. Now let's generate the audio signal using the predefined parameters. That is t equals to np line space minimum value, maximum value, duration, star sampling frequency. Signal equals to np.send to star np.py tone frequency star t. So the signal is assigned with sinusoidal wave. Now let's add some noise to the signal. That is noise equals to 0.5 star np.random.rand and so on. Signal plus equals to noise. Now normalize and scale the signal and scale it to 16-bit integer values. Scaling factor equals to np.power 2,15 minus 1. Signal normalized. Signal scaled. Now let's save the generated audio signal in the output file. It is write output file sampling frequency signal scaled. Now extract the first 200 values from the audio signal and plot it. That is signal equals to signal colon 200. Now construct the time axis in millisecond. That is time axis equals to 1000 star np.arrange and so on. Now plot the audio signal, that is plt.plot time axis signal color black, plt.x label time milliseconds, plot while label amplitude, plot.title generated audio signal, plot.show. So basically we did the plotting of audio signal on plotter. So basically if you want to understand the code and all in depth, you have to study the math on the wave, then you will get it what all codes I have used, what is sinusoidal wave and all. So let's move to the output now. Open the terminal, run the command as python audiogenerator.py and see that it generated audio signal for time dimension and amplitude. Another thing, it generated one audio which we can play and it contains noise. Let's play and listen it. So that's it in this video on generating audio signal. Thank you for watching this video.